morning, everyone, and thank you for joining us. My name is Clint Olson, and I'm the sales engineer for the Jacksonville office. I'll be hosting the webinar today. Stan Weaver & Company is a leading manufacturer's rep in the HVAC industry with 5 offices serving most of the state of Florida in Jacksonville, Orlando, Tampa, Miami, and West Palm Beach. Stan Weaver & Company has an unwavering commitment to excellence, and we position ourselves with only premier HVAC manufacturing companies. After this meeting, in your spare time, please check out our new website at stanweaver.com. There's now a great searchable line card under the Manufacturer tab on our website. When you're in search of a product for your project design, always start at stanweaver.com. This is the 5th of a 10-piece webinar in the Stan Weaver series that we'll be hosting throughout the year. We appreciate everyone taking the time out of your busy morning to learn and educate yourself with a great industry manufacturer product offering. Just a few quick housekeeping notes before we begin with Mr. Ryk. First, this meeting will be recorded. Second, as previously stated, this is the 5th of 10 total webinars we'll be hosting this year. If you've made it to our previous webinars and now this event, you're another step closer to winning the iPad. Third, these presentations will be no more than 30 minutes in length, and then a Q&A session for a brief period afterward. Please make sure to put your questions in the Q&A section. Fourth, we've muted all attendees for the length of this meeting. We'll be utilizing the Q&A function within Zoom located at the bottom of your screen. So again, if you have any questions throughout the presentation, please make sure to submit them there. Address them at the end of the presentation. Lastly, there is a survey at the end of the event. Please take the time to complete and submit this survey for us. We'll review all submissions and we'll use these comments to improve the series for us and all attendees in the future. Now, with no further ado, I'd like to present our speaker and topic for today. Mr. Ryk Williams has an MBA, Bachelor of Science in Mathematics, and is currently the Southeast Regional Manager, Humidification, Carel, one of the world's leaders in controlled solutions for air conditioning, refrigeration and heating, and systems for humidification and evaporative cooling. He has more than 8 years of experience in the humidification industry, working with a full range of engineers, contractors, and both large and small commercial and industrial end users across numerous markets around North, Central, and South America. In today's webinar, we'll discuss the hows and whys of adiabatic and isothermal humidification to provide an understanding of the design, manufacturing, and distribution of control and humidification solutions for the residential, industrial, and commercial segments in the HVAC market. We'll review solutions for each application segment where humidification systems are integrated into AHUs, ducting, or in-space applications, and discuss specific markets such as healthcare, electronics, manufacturing, printing, and packaging, where commercial, industrial, or residential humidifiers are commonly used. And now, Ryk, the floor is yours. I'll turn it over to you for the next 30 minutes.
Okay, thanks, Clint. Appreciate the introduction. And let me bring up the presentation so we all see what we're looking at. And it should be up now. Just make sure everyone can see that. But before we get started, Paula's got a quick survey she'd like to put up. It'll take just a couple of seconds to answer a question or two. I'll give about 30 seconds to go through that, and then we'll get rolling with the discussion today. All right. So today we're going to discuss the hows and whys of adiabatic and isothermal humidification. What I'm going to go over today is a review of the technologies and applications where these are used. The biggest 2 questions that I get for humidification equipment is, number 1, do you know where you are? It's humid here already. Yes, I get that. I'm based in Houston, so I understand what humidity is. With the humidification systems we provide, they are for use inside facilities where we need to be able to control humidification levels as part of process control for our industrial commercial manufacturers, as well as in the humidification market. We have to maintain it at certain levels depending on state and federal guidelines. For example, in the state of Texas, the health department requires 30 to 60% RH in a healthcare facility, period. Not if you think it's a good idea, or not if you want to do it, that's what they require. And even within healthcare applications, there's different ranges of humidification levels. For example, an operating room, they typically use around 50% relative humidity in the space. And then the next question I get is, okay, I get why I need it, but where the heck would I use it? So as I go through the presentation, I'll mention and go through some of the details on specific applications. So when we get started here, we'll go through that. I always like to bring up the difference. Humidity is what's happening outside at any given time. We're concerned with the relative humidity level inside the facility because we need to know how much moisture the air can hold at any given time for specific applications so that we're maintaining the optimal humidification levels for what's happening inside of a facility. So a couple of things here, again, why humidify? If you look at the industrial commercial markets, which we provide systems into about 25 different industrial markets around the world, if you look at the main factor among all of them, regardless of the type of industry, it's all about process control for that manufacturer. For example, in electronics manufacturing, they need to keep between 40 and 50% RH. If they don't, they can run into electrostatic discharge issues. They wind up blowing up boards and doing damage to their boards, which impacts their overall operations. Excuse me. As I mentioned at the beginning, there's two types of humidification: isothermal, which is steam, and adiabatic, which is atomized water. And I'll talk a little bit more about that in a moment, but there are applications like data centers, for example, where they need to have humidification for multiple reasons. In data centers, it's just a lot of electronics and banks of computers, and they can run into issue with electrostatic discharge issues in the space, and they could short out a computer or a bank of computers, and then suddenly they're not able to provide the data to the customers that are paying for access to that. So humidification helps maintain or lower the likelihood of an ESD occurrence, but you have all these computers in a fairly enclosed space generating a high heat load. So how do you deal with that at a cost-effective manner? And that's where adiabatic humidification comes in. It does provide a cooling effect, and I'll discuss that more in a few moments. And then lastly, on healthcare, it is the biggest market for humidification, primarily because it's regulatory requirements at both the state and the federal level. There is an organization called the Joint Commission that provides accreditation to hospitals around the country. And humidification and having humidification systems in healthcare facilities are part of their checklist when they're going through recertifying hospitals. So one of the things in the healthcare space is what this is related to. This is called the Sterling chart. This has been around ASHRAE quite a bit. If you're not familiar with it, this is a study that was done that was looking at what's the optimal humidity range in a healthcare facility for patient health. And it determined that 40 to 60% RH is the appropriate range for patient health, because at that range, the bacteria and viruses and things that can make patients sick don't like to live in that environment. So it either reduces them to a level where it significantly reduces the chance of someone getting sick from something they acquire in the hospital. Here with the other markets that we look at, the ones that we do quite a bit of business in, again, I mentioned the electronics manufacturing. I worked with a small electronics manufacturer, and the owner called me and said, "Hey, I'm tired of blowing up $15,000 boards. Can you help me out?" So, we looked at his facility, provided recommendations for humidification systems so that he'd significantly lower that chance. The processing of food material, this is mainly related to crop storage and crop usage. I had one project a couple of years ago. The owner was in the wholesale banana business, and he would buy 180 tons of bananas at a time and then put 30 tons in 6 different silos, basically storage bins or storage areas. And if the humidity wasn't kept at 70 to 75% RH, the moisture would dry or evaporate out of the bananas. And he told me, "I'm buying 30 tons and I'm shipping out 29 tons. So my profits are literally evaporating. So I need something to keep the moisture up in the product while I own it. We look at the speed of chemical reactions. This is primarily focused on composite manufacturing. When you have the correct RH level in composite manufacturing, which is typically what I see is around 50 to 55% RH, it helps cure the composite material quicker, stronger, and reduces the chances of dimensional stability with the material as it's going through the production or manufacturing process at the facility. Painting quality, this really refers to paint booths. We do commercial paint booths throughout the Southeast. We do the Toyota manufacturing plant in San Antonio, the Nissan manufacturing plant up in Tennessee. We do the Boeing plant down in South Carolina. We've also just recently fielded one of our adiabatic systems to the brand new North American maintenance facility for Airbus. So all those are for paint booth applications. What happens is you need to maintain, again, high humidity levels, 70 to 75% humidification level. If you don't maintain that, what happens is that you get too much overspray with the paint. And so there's just a lot of waste, which means it's costing somebody a lot of money. Or the paint doesn't dry correctly. You get runs and drips and bubbling, and they can't ship out planes and cars with defects in them. So just, again, more time to fix problems. Then we look at quantity of the dust in the air. This is about dust control. Excuse me. So I worked with a company that manufactures 53-meter windmill blades. And part of their finished process before they ship the blades out is they join the two halves of the blades together, and they send a team of 12 people with DeWalt palm sanders to sand and do finish work on them. Well, they had so much dust in the air that their dust suppression system wasn't able to keep up, and they had a 50,000 volt discharge in the space. So they said, hey, we need to do something to fix that. Well, the adiabatic humidification provides that twofer effect with the dust suppression. It provided the humidification they needed for the curing of the composites that they were working with. But because the adiabatic humidification atomizes water into very small droplet size, it's able to encapsulate dust particles in the air and makes them too heavy to float, and then they drop out, and then they're cleaned up as part of maintenance when they're on the floor. So that'll just give you an idea of some of the different markets, some of the different applications that we see. Again, that's not all inclusive, but just some of the highlights to show the wide range of systems. So when we look at the two core technologies, when I started doing this back in the very beginning, they said, let me just give you humidification at the kindergarten level. Isothermal, you're boiling water to get steam. Adiabatic, you're spraying water to provide the humidification. I mean, when you get down to just simple super terms, that's what it is. With isothermal, we're using electricity or gas to boil the water to provide steam into the duct or the air handler. Again, all of our products can be installed with the distribution system in a duct, an air handler, or directly in the room where it's serving. With adiabatic, we're taking supply temperature water, whatever that is, and just atomizing it into the environment. We have several different sub-technologies we'll talk about in a moment that obviously have uses that we see more often in certain applications than others. So here, what we'll talk about real quick is kind of compare and contrast the two, why you would select isothermal versus adiabatic. Typically with isothermal, we see these in smaller load applications. By smaller load, we look at about 2 to 250 pounds an hour is what we're looking at when we consider a small load. The install on these systems are pretty straightforward. Plus, the mechanicals who are involved with installing systems have typically installed a steam humidifier before. So there's some knowledge out there already, which makes it a little easier. And the maintenance is pretty simple and straightforward on these. The downside to the isothermal is that when you start getting into larger loads over that 2 to 250 pounds an hour, the operating costs get significantly higher than adiabatic at that same load or capacity level. A good rule of thumb that we use to just looking at the electricity cost to boil water. For every dollar you're spending on the steam humidification, you'll spend a penny on the adiabatic. And I had one engineer pop up from a meeting I was in, just said, "You're a liar." He just blurted out from the back of the room. What drives that cost difference is that it takes about 340 watts of power to provide 1 pound of steam humidification. While on the adiabatic side, you can provide that same 1 pound of humidification using 2 watts of power. So that's where you see the cost savings difference. And you start looking at having large loads at several hundreds or thousands of pounds an hour, then you start understanding the cost difference between the two. The adiabatic, everything's flipped. First cost is generally a little more expensive. At the lower end, the install is a little bit more complicated because there's more components, and most of the mechanicals have not installed an adiabatic humidifier before. So it's that learning curve they've got to go through. And then the maintenance is a little bit more involved because you've got more equipment, a bigger equipment package than what you do on the isothermal side. But then the plus side, as I mentioned, that cooling effect. The cooling effect and the operating cost difference. And with the cooling effect, because we're just taking supply temperature water, again, whatever that is coming into the facility, and spraying it into the environment, it provides a cooling effect. And people ask, okay, how much cooling can I expect? And a rough rule of thumb we use is for every pound of water you're atomizing in the environment, you're pulling about 1,050 BTU of heat out of the space. So it's not comfort cooling, but you'll definitely get a delta T with that. So just real quick, one thing, we do have a program called Humidify Now. If you want to have access to, as an engineer, you're able to get in and design and select and play around with different options. And the system provides you real-time design selection and gives you, show you psych chart and generate all the mechanical information that you need. Again, Clint or Eric can help you out with that. So when we look at the adiabatic technologies, we don't provide the wetted media. I just throw that up there because if people are familiar with it, they generally are familiar with the wetted media, also known as a swamp cooler. That system is a maintenance hog, which is why it's starting to fall out of fashion. The other 5 we do provide the centrifugal system. This I used in tobacco for tobacco companies in their leaf testing rooms up in the Carolinas. Also provided these to hospital pharmacies. This is a kind of a good entry-level humidification system when you need a small load on these. There's a rotating disc that spins super fast inside. Water's dropped onto it, thrown up against the side of the humidifier, and then blown out through the triangular vents you see in the front. The ultrasonic. The way this technology works is there is a piezoelectric membrane in the humidifier, and the humidifier are the 2 little white boxes you see on the right-hand corner of the ultrasonic section here. Those are our smallest. They can do 1 and 2 pounds an hour, but obviously we have bigger ones. And then the distribution systems you see behind it, the ones with the black tubes, would be mounted on the wall and provided the humidification into space. The one on the left with the white pipes would go into a ductor and air handler. Then we have a couple of pressurized systems. The medium pressure provides pressurizes the water about 350 PSI, and then sends it out through supply lines to the misting grid, which you see to the right of that white cabinet. This is where you need a good level of control because we know not every application is going to be a critical application. So if you do have a critical application, then the high pressure system is what you'll want to look at. It is designed for tight control, so we can keep the humidification level plus or minus 2% to set point, regardless of the size of the facility. The other advantage that we have when you're looking at a high pressure system is the cabinet or the pump cabinet that we see there on the left, right under the words high pressure, can handle up to 12 zones. So with the pump cabinet being the bulk of the cost of the system, you can take this and say, put a distribution system in up to 12 different ducts or air handlers. And then we put a zone controller out next to where the distribution system is and be able to run all 12 of them off a single pump cabinet. So that's something you don't see outside of our systems in the industry. Again, we can put a duct or directly in the room. The compressed air system, similar, instead of using any kind of pressurized water or pressure pump, we're just using compressed air to provide the humidification into the space. The only caveat I mentioned on compressed air is people generally say, well, I've got compressed air on site, which I mean, you have to have anyway, but just ensure you have enough excess capacity if you're going to use on site. If you don't, then you'll have to get another compressed air system there. Here, I'd just like to show briefly on the adiabatic. If you look down in the bottom corner, this is ultrasonic humidifiers that are being used here. That white mist or the fog that you see, that's the technology working correctly. If you don't see that, alarm bells should be going off because you've got big problems with that. And so this picture is taken in an air handler to show that. And here you see tight precision, plus or minus 1% to set point with the ultrasonic. Here this is a high pressure system. If you look down at the bottom left, this is the distribution system in a duct. Couple of comments that I'd like to mention because we get a lot of questions on this. On the right-hand side, you'll see the misting grid is what we call it. And then you see that white fog or mist coming out of the nozzles. Again, that's what you need to see. If you don't see that, you got problems. Then on the far left, you'll see the mist eliminator. Because when we design a system, we'll be able to tell you what the absorption distance is. And the absorption distance is from the misting grid on the right to the mist eliminator on the left. And we know that 100% of the water will not be absorbed 100% of the time into that absorption distance. But we get at a high enough efficiency where no one chases 100%. But we put that mist eliminator in so that we avoid having any excess water downstream. And then in this section of the duct, it needs to be stainless. And then slope the drain pan into the center and just put a P-trap to catch any of the water that's not used. Then we look at isothermal. We'll start in the middle with the electric. These are the electric electrode system is the one that started all of humidification technology. The electrode system, the way it works, you see that little blue pop out bubble to the left of the unit. That is the inside of the cylinder. The cylinder is basically where all the magic happens. There's a wire mesh inside that attracts the minerals in the water that creates a current, and it boils the water to provide the steam. The caveat I mentioned with the electrode system is only use potable water. Do not use any other type of water because if you use any type of treated water, you won't have enough minerals in the water to create a high enough charge to provide the load that's needed for the system. So if you have critical applications or you need to use treated water, the resistive unit is the one that we provide. On the right there is a heating element. And just think of this system as like your hot water heater at home. It's just a much more highly engineered water heater. Some of the things we do to help with prolonging maintenance intervals on the system is with this one, if you're using the treated water, typically RO is what we see. The heating element that we use is a titanium heating element. We're the only ones in the industry that do because minerals don't like to adhere to titanium. So that means longer maintenance intervals. Same thing, the tank is wrapped with Kevlar on the inside. Minerals don't like to adhere to Kevlar, so it helps prolong the maintenance intervals. And then the gas-fired unit, same concept as the electric, which is using gas to boil the water instead of electricity. Gas units are typically installed outside, curb mounted on a roof, but we have seen some be installed inside as well. There on the right on the distribution systems, the three that are shown are three most popular for the steam systems. Excuse me. And we get numerous requests for, hey, I need as short as absorption distance as possible in the duct or the air handler because I don't have a lot of free space. So depending on the size of the duct or the air handler, we have three systems that will give you super short absorption distance. That grid that you see in the top left of the distribution systems box, excuse me, that one is designed for large loads, 700 pound an hour requirement, and a 6-inch absorption distance. Excuse me. And then the single tube that you see there on the right, same technology as the big manifold. It's just designed for small ducts, like say 14 by 18, 16 by 20, things like that, where you have a smaller load. And then over the last couple of years, there's been a significant increase in the number of ducts that are on the smaller side, but wanting as short of absorption as possible. So the one that you see in the bottom is similar to one at the top. It's just designed for small. Any ducts less than 24 by 24 where you need ultra short absorption. We do have systems that provide much longer absorption distance if you have the free space, but these are put up because these are the ones that we see most often on these. So here, another thing I like to mention, we do have a pressure steam system. So if you've got a boiler or a steam plant that you're working with and you want to just tap off the steam there, we provide the pressure valve configuration and the manifold, and then you'll be set to go on that. And then one thing I forgot to mention, because Carel is a controls company, we have a wide variety of controls. We obviously put our own controllers on all of our equipment. So on the systems that are designed for kind of an entry good level of control, like the electrode unit in this case, we put a Modbus control on it, and then you have the option to upgrade all the way up to MSTP 485. On the resistive unit, because we know that typically goes into critical applications, for example, in hospital applications, if say the hospital is adding on a new OR suite or a burn unit or an ICU unit, the resistive one, as we see, used almost all the time because it's designed to handle treated water. It keeps the RH to plus or minus 1% to set point in the space. With that, so we put our top of the line controller on it right off the bat. So again, flexibility with that and the ability to have multiple controls as options for you. So just real quick, go through some of the applications. I've mentioned some of these already. Clean rooms, that is both pharma and electronics manufacturing, where we've done projects. Data centers, telecommunication centers, similar issues between the two as far as ESD and heat load. Some of the other interesting ones that have done, textile industry, worked with a company that makes commercial screens, screens for commercial buildings. In their application, they have to maintain 60 to 65% humidity for optimum performance of their production line. Let's see. The greenhouses down at the bottom really should say grow houses. That's more in line with marijuana grow ops right now. Humidification is critical during the first 10 weeks of plant life and very high humidity in that industry with that. Again, just some pictures to highlight some of the different applications, some of the industries that we've done systems in. And one of the things that I'd like to want to mention on the adiabatic technology here, there was a change that came out to ASHRAE 170, the addendum in 2017. And up until that point, ASHRAE did not allow anything other than isothermal humidification in a hospital, facility. So the change that came out said you can use adiabatic humidification in a healthcare facility if you do three things. One, the distribution system has to go into the duct or air handler, no problem. Two, you have to use RO water. It specifically calls out RO water. Again, our system is designed to handle potable, RO, DI, ultra pure. And three, you have to use a UVC sterilization light. And the issue with that is helps treat the water for Legionella, which is a big concern in a healthcare facility. So I just like to bring that up because we're seeing significant growth in the adiabatic technologies in a healthcare facility. And as more and more people find out about the change to 170, the interest continues to grow on that. And with the treated water, we do provide fully skidded RO systems and the UVC light with all of our adiabatic technology products. So with that, I'll take any questions or we'll turn it over to Clint.
Awesome, Ryk. Thank you. That was fantastic.
You're welcome.
Currently, we don't have any questions waiting in the Q&A section, but we'll give it just a few seconds here and So if anybody has any questions, please put them in the Q&A portion at the bottom of your screen. Otherwise, feel free to reach out to any one of your Stan Weaver reps and we'll help you directly with any project information you might have. So we'll just give it another few seconds here and then we'll end the webinar. All right. If no one else has any other questions, I think we'll call it for the day. Thank you everyone for your time, and we'll see you next month for our next webinar.